All right, so we're jumping into section 1.1. Our objective is to name and sketch geometric figures. Our warm-up doesn't have a whole lot to do with geometric figures. It's more about algebra. But we are graphing these inequalities. We have a line here, but it needs to have numbers on it if we're going to graph an inequality. I don't know about your other math teachers you've had before, but there's a certain number that I always like to have on my number lines. Does anybody know what it is? 0. I like 0 to be on there somewhere. It doesn't always have to be in the middle. If you want it to be further to the left or the right, that's fine. We should also probably have the number that we want to graph. Should 1 go to the left or the right of 0? To the right, because it's positive. If you also want to put a -1 on there, you can. You don't have to. What's the next important thing we need to remember? Good. Open versus closed. What do we need in this case? Closed, because it's an equal bar underneath that sign. So if we've got the equal to bar, it's got to be a closed circle. Last thing we have to do is shade to the left or right. The left, because it's less than. Less than goes to the left. Yes?
Do you mind if we put it like above the line?
That's fine. We won't really do a whole lot of these because this is not an algebra class. So, yes, that would be okay if you did it above the line. All right, on number 2, again, gotta have 0. You need to count by an even increment, so that means I can't just plop a -2 and a 3 and be done with it. If you want, you can count by 1s, you can count by 2s. That's what I'm going to do because I don't have a ton of space. But whatever increments you're going by, they better be even increments. Not even versus odd, just consistent. Might be a better word. So I need to put points on my line. Where do I need points at? 3 and -2. Are they open, closed? Closed. So -2 is easy. Close point. But 3, I didn't label. So where is that point going? Beautiful. Okay, then we have to decide where we're shading. Where are we shading? In between them. So X is in between the -2 and 3. So that is where we shade. Now sometimes in algebra we learn that the -2 is shaded this way and the 3 is shaded the other way, and you look for their overlap. Again, this is just a review. This doesn't have a whole lot to do with what we're talking about today, except for these figures, the lines themselves. An undefined term would be words that do not have a formal definition. Examples of that would be our next few definitions. Point, line, and plane are all undefined terms. Okay, again, we don't have a picture or notation for that, but for point and line we will. A point has no dimension and is represented by a dot. So for our picture, it is simply a dot. And we always not always. We usually like to label our points if we're going to talk about them. So give it a capital letter, like point A. So our notation for that would be to write out point, capital A. Sometimes you will see points named just with their capital letter. So an alternative option would just be to talk about it as A. Make sure that you're using capital letters for points. A line has one dimension. Try to underline the ones that you have to fill in. It is a collection of points that extend infinitely in two directions. Our note there says you only need 2 points to make a line. Now, if you took Algebra 1 here last year or previously, you might have, when you were graphing lines, needed more than 2 points. Some algebra teachers require 3 or 4 points, but technically by the definition, 2 points determines a line. So we have a diagram for that. Of course, we're going to need a couple of points. Our lines need to be straight as can be, so if you have a straight edge, I would use one. It's going to have arrows on both ends of it. Those arrows are important. They need to be there. That's what shows that it extends on in both directions. Our points, again, should be labeled. A and B are common labels. You may also see a small cursive lowercase letter near one of the arrows. So I'll use a cursive L. That is not a point, that is talking about the line. So our notation, we have a few different ways that we can talk about it. We could call it line L using that cursive lowercase letter. We could call this line AB using the 2 points. Another way of saying line AB is to have a little line on top of the letters AB. So if I were reading this on a page, line AB, and this symbol notation would also be read line AB. Lines can be named forwards and backwards. So we could call this line BA. And again, you can write it with the line on top of the 2 letters BA. If we had more points labeled on our line, we could come up with even more names for it. On we go down our chart. A plane has 2 dimensions. 2 dimensions. It exists through any 3 points not on the same line. So through any 3 points not on the same line, there is exactly 1 plane. Planes are a little bit harder to represent in a picture. So usually you will see a plane kind of looking like a parallelogram or a quadrilateral of some sort. Looks like a box. We should have at least 3 points that are not on the same line inside of there. So I'll use points A, B, and C. You may also see a bold capital letter in one of the corners. So since I have a hard time showing bold, I'm going to change color and put an M up there. If you want to try to make it bold with your writing utensil instead, you can. And that bold letter, you'll notice, does not have a point by it. This is kind of similar to the whole cursive letter thing. Okay, so when we go to name it, we could call this plain M, just using that bold letter. Again, I'm trying to make this one a little more bold. Or we can call it plain ABC, using those 3 non-collinear points, or points that are not on the same line. Okay. Next up we have collinear points. You might be able to guess. Those would be points that lie on the same line. You could draw a picture for that. You could put a line that has a bunch of points on it. All of these points would be considered collinear. You can name them anything you want. Any amount of points that are on the same line are collinear. I don't believe the definition is explicitly in our notes, but non-collinear, you might guess, means that they are not on the same line. So if you want to make a note of the word non-collinear, you can. That just means they are not on the same line. The antonym, I suppose we would say. Okay, next we have coplanar points. Points that lie in the same. Any guesses? I think I heard one person say it. Plane! They lie in the same plane. Again, you could draw yourself a little plane and put any amount of points that you want in that plane. Could be 4, 5, 6, 10. Doesn't matter. They're all inside that same plane. Similarly, we could talk about the word non-coplanar, which would mean that they do not lie in the same plane. Non-coplanar, not in the same plane. Here it is. Defined terms would be terms that can be described using known words. That one's a little silly to me, but there it is. All right, it's also in your textbook. A line segment is more interesting. It's a collection of points with 2 endpoints. So it's got a beginning and an end. Both of them are called endpoints. So we've got a segment, and we have points on the ends. Notice that my line piece, the straight part, does not go past my points that are on either end of it. There are not any arrows involved. We do still label our points, so we could still label them A and B. Naming line segments is pretty similar to naming lines. So we could call it segment AB, or you can put AB with a bar over the top of it to represent a little segment. You can also name a line segment forwards and backwards. So we could call this segment BA. And we could put the BA with the bar over the top of it. Usually when we talk about segments, lines, rays, we like to use the shorthand. Okay, you won't always see it written out. So I would get comfy with the shorthand part. A ray is a line with a definite endpoint that extends infinitely in one direction, like the band. Haha. Okay, so one endpoint, one arrow for a ray. Endpoint, line, arrow. Usually you will see another point labeled on it so that we can name it. You don't have to use A's and B's, but you can. So again, we could call this ray AB, or our shorthand is to use a little ray over the top of AB. We cannot name this backwards. When you name rays, you have to start with the end point and head towards the arrow. So if we wanted to name a different ray, we would have to draw a different ray, which we could do. Okay, so this is another example of rays, but this one would be called ray BA. We got to start with the end point, head towards the arrow. It doesn't really change what the notation looks like. We still make our little ray over the top pointing to the right. Opposite rays are rays that share the same endpoint but extend in different directions. Or really opposite directions. The note there, opposite rays are, well, let's see if we look at a picture of you can tell me what goes in that blank. So let's say we've got endpoint C, and we extend it out one way towards point B, and we extend it out the opposite way towards point A. What do these opposite rays actually look like? A line. Opposite rays are a line. And we could name both of these rays, so I'll just do the shorthand only this time. We have ray CB. We also have ray CA. When we put them together, they form a line, so you could also call this line AB, line AC, line BA. We have lots and lots and lots of options for naming the line. I won't list them all out. Next up we have intersection. Intersection is a set of points that figures have in common. Set of points that figures have in common. We could draw a couple pictures of intersections. We will see some in our examples coming up here. One of the most basic ones would be the intersection of two lines. The intersection of two lines is always a point. You can label it if you want. What is much harder to draw would be the intersection of two planes. The intersection of two planes is going to be a line. I'll try to roughly draw this. If you can't copy this down, it's fine. You will see this in your book also. Let's make the other one kind of go in this way. This is not the best drawing, but these would intersect here if you kind of think about if you were to put two pieces of paper, like one cutting through the middle of the other one. There's a line here where they would intersect each other. So this whole set of points would be their intersection. All right, what type of intersection is shown? So that question's a little bit vague, but we'll talk about what is intersecting and kind of where they intersect. So for this first one, what type of objects do they show intersecting? What do you think this black thing is? A line, possibly a segment. So a line intersecting, what do we think this? A plane. So if we're using words off of our definition list, this would be a line intersecting a plane. How many points do you think that happens at? One. I would say there is a single point of intersection there. Okay, on that second one, it's probably a little easier to see on the board versus the black and white version in your notes. What type of object do we see here? How many planes? 3 planes. So I would say that this one is the intersection of 3 planes. So you can kind of see the planes making the X and then one plane cutting through them. Now some of you might be able to see this without me kind of drawing it, but they all meet here. So their intersection is what did I draw? A line. Their intersection is a line. That would be a very hard diagram to freehand. All right, the last one is a little bit tricky because one of the objects that is there we haven't really talked about yet. But if we were to ignore the white part here, does anybody know what this object is called? A cone, good. We'll talk about cones more later in the year. So the cone is being intersected by what? A plane. So we've got a cone intersected by a plane. Now, their intersection is also something we haven't really talked about yet. It's almost a circle or some sort of round oval object. So their intersection, let's see if I can find a good color to do this in. Their intersection would be all of these points in this round object. We don't have a great name for it, especially because it looks like it gets cut off before the bottom of it completes. This is a little bit of a preview. Or if any of you end up taking Algebra 2 Advanced, I believe they still cover conic sections. So if that is in your future, you might see diagrams like this again next year. Just a little preview. Questions, concerns? Okay. Let's move on. Thinking to myself, why don't you take a couple minutes and see if you can answer these questions, and we'll go over them together. If you would like to quietly discuss them with someone near you, that's fine. See if you came up with the same answers. Some of these could have more than one correct answer potentially. And we'll go through possibilities in just a minute. Good, so line and L like that. Wonderful. Okay, so there's one other name for that one. Did anybody get the last name? Caitlin?
Would it be line cursive B?
Good, we could call it line B. You could put it cursive or italicized, something along those lines is fine. Should definitely be lowercase. And maybe, Yanni, you were saying this and I just misheard you. There are other options for line LN other than NL and B, because there's another point on that line. What other point could we have involved? M. So M and N sometimes sound so similar. So you could have also used M with either L or N, and you're talking about the same line. So ML, LM, MN, NM. Okay, we've got lots of options. So as long as you had two of those, you're good. All right, what about 1B? Ariana? Ariana, sorry. See him trying. Q, M, and, well, A is not a point. So you're very close. L, M, and N. Good. So we want points. L, M, and N. If you are listing points, you really should be separating them by commas. Otherwise, you are technically talking about other geometric objects like planes or other figures. Okay, so if you would put QMA, A is technically not a point. It doesn't have a dot by it, so that's why that one doesn't work. So LMN is our only option for 3 collinear points. All right, 1C for coplanar points. This is what I get for standing in the back of the room. Brianna? Is it Brianna?
Brianna.
Okay, good. I got that one right.
L, M, N, P.
L, M, N, and P are all on the same plane. Good. Again, only option for that one would be L, M, and P. If you list them in a different order, like P, M, N, L or something, that's fine. 2 other names for plane Z. Or if you even just want to give me one of them. Atea?
Line L, M, N, the line above it.
I almost like that until you said the line above it. Just plain LMN. Actually, I don't like that. I almost like it. I'm sorry. I like the L and the M. Does anybody know why I don't like using N with that? They're all on the same line. So that's one of those real tricky parts about planes, is that you need 3 points that are not all on the same line. So what point would I have to use? P. So LMP would be an option. But then that kind of makes it easy, hopefully, for us to see one of our other options. Would be, let me learn a name real quick. Kara.
Plain M and P.
M and P would work. Good. 3 points not on the same line. There are other options. LNP would be an option. Would that be our only other? That might be one of our only other ones. So we've got a few options for that one. The other thing that I will mention is that when we name planes, we just use the word plane. We don't put anything over the top of the points. Geometry can get a little bit tricky for some people because it is a little nitpicky. And I apologize for that if you're somebody who's not a big fan of the little details. But geometry is pretty heavy on details. All right, letter E, a point that is not coplanar with L, N, and P. We really only have one good option for this one. Sydney. Q is not coplanar with those. Questions on example 1. Okay. Give another name for segment VX. Who got one? Anybody I haven't heard from yet? Or haven't gotten a chance to learn their name yet? I should just pick on people. Usually try not to do that in the first week. Ariana, did you have it? What did you think? A line with W. And I have to disagree on that one. Because if you're talking about WX, you'd be leaving off this section over here. Okay. You're going to have to tell me how to pronounce your name for the first time. Maja. Okay. I'll do my best. I'm sorry. What did you get? Very good. We can name it forwards or backwards. So we could call that segment XV. Letter B, name all rays with endpoint W. Now, even if you didn't get all of them, if you got some of them, I'll take it. All right, Ataya, what'd you get? Yep, we go out in all directions with the little rays over the top, I hope. W1, WX, WZ, and WV. It's important that you start with W every time. It's got to start with W. If you were to start with any of the other letters, you're talking about a different ray, not one with a endpoint at W. Anybody come up with 2 pairs of opposite rays? Or even just 1 pair of opposite rays? Majay? Good. WV and WX point in opposite directions, so they are opposite rays. WV and WX. The other pair of opposite rays would be Ariana? WYWZ. All right. Are rays VX and XV the same ray? Let's do thumbs up, yes, thumbs down, no. Should be seeing thumbs down. Those are not the same ray. No. So I'll try to highlight real quick. If we're talking about ray XV, VX. We're starting at V and we are headed towards X and we keep going. If instead we are talking about ray XV, we're starting at point X and headed towards point V. So they overlap a lot, but they are not the same. So your explanation could be they don't have the same endpoint. That's a really simple way of saying it. Don't have the same endpoint. Running myself out of room. All right. Now, we are going to be pausing our notes here. So this is where our video will end, but don't put your notes away just yet.